Hi everyone and welcome back to Maths and Physics with Mr. Simons. Today's lesson on cubic functions. It comes from November 2013. Drawing is given. It's on cubic functions. And the main question here is whether you can find the equation of the cubic function given only one turning point. Once you've done that, you are able to find the questions, or not the questions, the answers of the other questions. Right, so the question itself. Say the function is defined by f of x equal x cubed plus ax squared plus bx plus 2. If you look very carefully there, they've given you a value there in front of x cubed, which is the invisible 1. Sketch below p minus 1 and minus 1 there, and r are turning points. So the graph turns at these 2 points. Right, show that this a here is 1 and that b there is minus 1. And so otherwise determine the x-coordinate of r, so we want the turning point. And 9.3, write down the coordinates of the turning point of h, if h is defined by h of x, equal to f of x minus 4 for 2 marks. Right, so that first question for 6 marks, let's tackle that one. So we show that a equal 1 and b equal minus 1. So we have f of x equal x cubed plus ax squared plus bx plus 2. That was given to us, and we've been given the turning point p minus 1 and minus 1. So I assume you remember to get the x value of a turning point, we always use the first derivative. First derivative equal to 0. Then we simplify and we get the x value, and that minus 1 then goes back into the original equation. So this minus 1 goes back in there to get the y value. So now to get minus 1, we're first going to find the first derivative here and use the minus 1 to create the equation. Right, so first derivative, we have, or not first, I'm not going to go with the original equation. You see, I've typed differently, but yeah. So minus 1 goes in there. In the place of x, and minus 1 goes in place of y. Right, so there I have minus 1 cubed minus 1 squared times a plus b times minus 1 minus 2 equal minus 1. If I simplify, that minus 1, if it goes over, would become plus 1, so that's 0. So this minus 2, when it goes over, would be plus 2 plus... not plus, plus a minus b. Right, so I have 2 equal a minus b. Right, and if I make either a or b the subject of the formula, I'm left with b if I take it over. Right, and there now going second derivative, so there you see I've taken b over, b equal a minus 2. I bring 2 this side, so that's my equation 1. Right, now as I said, explain to get this minus 1, I have to use the first derivative. So first derivative there, f prime x equal 3 times 1, which gives me 3. 3 minus 1 gives me 2. So therefore, 3x squared. 2 times a gives me 2a. 2 minus 1 gives me 1, so 2ax. 1 times b stays b, x falls away, and the first derivative of a constant equals 0. Right, now I'm going to substitute in minus 1. So there my first derivative equals 0, and x there minus 1 squared plus 2a minus 1 plus b. Right, if I simplify, you see there I've made b the subject of the formula. So yeah, I'm also going to make b the subject of the formula. So that's minus 1 squared becomes plus 1, so that's 3. If I take it over, it would become a minus 3. This is minus 2a. If I take it over, it would become positive 2a. Right, so I have 2a minus 3 equal b. That's my equation 2. Right, so now I'm going to equate 1 and 2. So there b and b is the same letter b. So I can now say this a minus 2 equals the 2a minus 3. Right, so 2a minus 3 equal a minus 2. If I take over a is positive here, it will become negative on the other side. So 2a minus a would give me a, and there if I take minus 3 over 3 minus 2, which will give me 1. So a equal to 1. Alright, if I substitute back into either the first equation here, 1 minus 2 would give me p as negative 1. Or I can go where 2 times 1 is 2 minus 3, which gives me negative 1 for p. Right, so there p 1 minus 2 equal negative 1. So now I'm done and I solved. 1 mark there for correctly substituting minus 1 in the place of x and minus 1 in the place of y. Right, second mark for getting the equation in terms of p. Third mark for finding first derivative. Fourth mark for correctly substituting minus 1, the x value, into the first derivative. Right, next mark there for making b the subject of the formula. Right, and then basically my 6 marks for equating the two. No mark for getting a as 1 and b as minus 1, because there we've already stated what the answers would be, and that is your 6 marks. Right, let's go to the next question. Hence or otherwise determine the x coordinates of r. Alright, so we know r is the turning point of f. So hence at r we have to find the first derivative and make it equal to 0. My equation, after they told me that a is 1 and b is minus 1, would read f of x equal x cubed plus x squared minus x plus 2. So this equation I have to find the first derivative. So I'm going to say 3 times 1 gives me 3. 3 minus 1 would give me 2. 2 times 1 would give me 2. 2 minus 1 would give me 1. 1 times negative 1 would give me negative 1. And 1 minus 1 falls away. So the x power 0 falls away and 2 falls away. Right, so there, 3x squared plus 2x minus 1. Alright, so you can see there 3 times 1, 3 minus 1. 2 times 1, 2 minus 1, x. 1 times negative 1, x to the power 0 fall away, and the first derivative of constant always equals 0. So 1 mark for getting the first derivative correctly. Second mark, we always, very important that you equate this whole equation we found equal to 0. That is to find the x value of a turning point. Right, so there, 0 equal, and if I factorize now, I have 3x times x. It's a prime number, so it can only be 3x and x. And 1 in itself only has the factors 1 and 1. Alright, we need to get to positive 2, so there 3x times positive 1 gives me positive 3, minus 1x gives me plus 2x. So x then equal to 1 over 3, or x equal to negative 1. Alright, but if we look where r is, we already have negative 1, so we already have the coordinates of p. So we're not going to worry with the negative 1, but we're going to work with 1 over 3 on the positive side where r is. Right. So as you can see, the x equal minus 1, not applicable, because we already have p as minus 1 there. So therefore they said answer otherwise determine just the x coordinate of r for 3 marks. So my x coordinate of r would be 1 over 3. Right, and I assume you remember if we said get the x and y coordinates of r, that the 1 over 3 would go back into the original equation to find the value of the y for the r. Alright, so let's look at the next question. Right, so for 9.3 they say write down the coordinates of the turning point of h if h is defined by h of x equal to f of x minus 4 for 2 marks. So there we're working with f of x, the function. So we know f of x is x cubed plus x squared minus x plus 2. And we had a turning point at minus 1 and minus 1. R, I didn't find the y value, so I'm not using r, but only the value of p, which is minus 1 and minus 1. So we want a new turning point, h of x. Right, so the new turning point, h of x equal 2 times f of x minus 4. So in short, what this means, remember, f of x represents the y value, right? So the y value of this turning point was minus 1. So minus 1 is going to be multiplied by 2. And then it's moved 4 units down. That's what minus 4 means. So there, minus 1 times 2, minus 4. Right, so there, The x value hasn't changed, so as you can see I have minus 1, and my y now is minus 1 times 2 minus 4, that gives me minus 2 minus 4, which gives me minus 6. So my new turning point would be then minus 1 minus 6 for h of x. Right? So there's my new turning point, minus 1 minus 6. Right? I hope you enjoyed the lesson. I wish you nothing but the best. God bless. Bye.